There we go. Does that look right? Sure. Whatever you say. All right, so we have miscellaneous virus infections. You know these, so it's not like they're lesser known because, you know, we thought we didn't have to worry about them. So you could pretty much change this lecture because at the time, these were clinically significant, but just very uncommon for us to have to worry about. And that's totally flipped the script on these. These have become, you know, you just don't know. Each year could be one of these coming in. So don't take that as, oh, these aren't going to be important. I'm not going to have to worry about these at all, but they are going to be pretty fun to go through. The first one is pretty, you maybe heard of Hantaviruses. I don't know. I don't think you have, but you may have. Let's look at them. They're from the Virus family, Bunyavirinae. They're enveloped, their helical RNA kind of sounds familiar, right? They have 3 single-stranded RNA segments. I think that's the first one we've had with 3. Approximately 300 total members. There's only 12 that are human pathogens, and most are transmitted by mosquitoes. So arboviruses are arthropod-borne viruses. They're not arthropod-borne though, okay? They're born in rodents. So these are coming from our mice and one in particular. So when you have a virus in a rodent, that rodent is in your area. If it's expressing its urine, its feces, and the one that does this for the hantavirus is the deer mouse. And we got a picture of a deer mouse. I think you see it on the front page of your PowerPoints. The deer mouse basically is named that way because it looks like a deer. Okay, not that it has anything to do with deer, but it looks like a deer. So I always tell this story, like, so when do you find feces? Everybody found feces and know what that, because urine you pretty much know. I've got 2 stories with mice. So how do you know? How do you know you've been invaded by a mouse?
You found poop.
Poop, right? You recognize it. It's little black, little giblets of poop around the wall, around the floor. Maybe in your pantry, maybe in an attic, maybe in a mattress, on top of a mattress. So I always tell the story. We had kids were real little, and I just joined my in-laws had a deer camp down on a place called Big Island. You're familiar with that, but it's this strip. It's just a land mass that's in between the White River, Arkansas River, and the Mississippi River. So all 3 rivers flow around this land called Big Island, owned by a lumber company, but lease it out for deer hunting. So they have this cabin. So I go over there like, hey, let's go over. It's early in the spring. Let's go mud riding. Bring your 4-wheeler. Bring the kids. So I end up with both my kids going with me. I think Aiden was the youngest, just up, up and about, but he was still, had to be under 3, about around 3 probably. So we go into this deer camp, and the first thing I notice is dishes everywhere. Like, it's spring, these should have been cleaned and put away. They're just kind of all in the sink. I guess from everybody that visits, you just put your stuff in the sink. Notice this cup of water on the floor, a jug of water, kind of like a milk jug cut out and had water in it, and there was a mouse in there. Okay, probably about this big. So he's in that water. So they go, oh, just pick a bunk and get your sleeping bag and make yourself at home, and we'll go riding and come back. So I go, I unfold the mattress, and it's just full of poop, right? All this rat poop everywhere. So I'm like, this is not good. So this cabin is infested with rats. So I got my two little ones trying to be good with the in-laws, you know, try to be that team player. So I'm like flipping it over the mattress, and what are you doing? I'm like, well, kind of cleaning off poop from the mat. Oh, don't worry, you know, don't worry about that. It's no big deal. So you're thinking, well, maybe they've exterminated what they had. It'd be good night's sleep, right? Just had to clean it up a little bit. Hadn't been here. So we're going to bed that night. I got both my kids. I got like this double-sized sleeping bag. So I got both my kids, one on each side of me. And all I can hear is all night long. And I hear things like, there are holes in the wall this big. There are rats everywhere in that cabin. And I'm just like, if one jumps on this sleeping bag, I'm probably gonna have to leave. I'm probably just gonna wrap up the kids and head to the car and take off from here. Needless to say, I got no sleep all night waiting on rodents to drop onto my sleeping bag. So I don't know if you've ever been in that situation, but I just tell the story of my rodent-borne. So when you think, oh, rodent-borne viruses, oh, there's nothing to worry about there, right? There are situations we may find ourselves in that we do become in shed urine and feces from rodents. That wasn't deer mice in there, but it was definitely rodents. So the feces can become aerosoled by human activities such as vacuuming and sweeping the house. So what did we do? All right, we started cleaning the cabin, sweeping, dusting off the mattresses. So, you know, it's just route of transmission, inhalation. And one of the Hantaviruses, I love this one, it's sin nombre virus, no name virus. It's responsible for human infections. And if you've never been, I've never been, but I've always wanted to, the Four Corners, right? Where 4 states come together and you can put one hand in Arizona, one hand in New Mexico, a foot in Colorado, and a foot in Utah. And you can be in 4 states at one time. Anybody visited this place? Nobody's been to the Four Corners? You heard about it. I don't know what to teach in school anymore. You heard about the Four Corners where you can be in 4 states at one time? Okay, good. So this is where these cases are, okay? 1993 was outbreak, severe, healthy, among several healthy young people. It starts off as a pulmonary infection and causes acute respiratory failure, which can be fatal if untreated or misdiagnosed. So if you move out there and you're all of a sudden got like a young kid in the ER with respiratory failure, you may want to remember your Hantavirus lecture. So there's our deer mouse. They look so sweet, don't they? Just want to be a pet. That probably is a pet. There's our Four Corners. So if you're not familiar where that is, Utah, Colorado, Arizona, New Mexico. In that area. Sin nombre virus, Spanish meaning nameless virus. It is the etiological agent of Hanta pulmonary syndrome. So this is what's known as HPS. You can also have them in different places. I'm going to move this, going to change that so y'all can see. There you go. All right. So they have them in different places. We see US, Canada, Central and South America. We see the Bayou virus of Louisiana, the Black Creek Canal virus in Florida, and the New York 1 virus. So these are all Hantavirus outbreaks from rodents to humans. Symptoms begin anywhere from 10 to 30 days, so 2 weeks, a week and a half into a month. Headache, fever, body aches, flu-like symptoms, of course, that gets thrown out just all the time. They become more severe, and they can go to hemorrhagic fever. So basically what we're starting today is the hemorrhagic viruses. Okay, so these are the movie viruses. What we've always thought about, here comes the patient with hemorrhagic fever and blood coming out of everywhere. But it's just dealing mainly, since y'all are lab professionals, it's dealing with the inability to clot blood. Okay, so that's where it gets its name, hemorrhagic fever. Kidney disease and acute respiratory failure. We can identify it. We know IgM, acute, IgG antibody screens, enzyme immunoassays, enzyme and a method of choice. We can also do some diagnostic with the viral antigen in tissue. and amplification of the viral RNA in blood and tissue. So virus isolation from humans has failed to recover. What's the SNV like? What's that again? Sin nombre virus, like viruses. We've been unable to recover. Dum, 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 right? Thought you were done with this one. And here it comes. In the unlikely, shouldn't have to, are pathogenic, but what's the big deal about coronavirus, right? Y'all love that question. So this was the history. Okay, this was, hey, maybe we've had a couple of near misses and we should be a little more on point, and we weren't. So coronaviruses, of course, oh my gosh, they're pleomorphic, they're enveloped, they're helical single-stranded RNA viruses from the Cornoviridae family. They sore throat, common cold, and then we see these things. Then we see SARS, okay? And that's what I mean by the warning. We had some near misses. We had near misses with SARS, and we had near misses with MERS. And if you would have asked the healthcare organizations 2 years ago, are you worried about MERS? Are you worried about SARS? And what would the answer have been? No. What are those, right? I remember when we first brought this up, we brought up coronaviruses. The response from the class was, hey, I looked it up, like y'all do all the time, right? You look it up and it says, oh, it's just the cause of common cold. So we have human coronaviruses, common cold viruses, nothing more than that. Respiratory secretions, we already knew this with coronaviruses. We already knew they were spread by respiratory secretions. Seemed like there was some kind of new theory when COVID hit the second time, right? It was like a new theory, like how does it spread? What do we need to do? Is it going to be on this or on that? Or is it through this or through that? We already knew. We already knew transmission was respiratory secretions. It's right here in our lecture, right? Lab diagnosis rarely done in cases of the common cold because there was nothing really to worry about. So guess what? We don't have tests for this. Amazing, right? Amazing. We didn't have tests for this because we weren't worried about SARS, severe acute respiratory syndrome. 2002, this is what I mean by the warning shot. Pretty much 20 years ahead, right? 20 years, we had a warning shot. November, oh, what time? When did SARS come back this time? November, wow, amazing. How about that? It was identified, worldwide outbreak of respiratory disease, worldwide pandemic again, right? Not that we had one case, not that we had one area of interest. There was a worldwide outbreak. SARS in southern China. Oh my, no, there was nothing ever from China. This was all new. We weren't ever worried about something coming from China. Were we? 8,000 cases. Nothing to worry about. And this is what we used to say, don't worry. This was the information that we said, look, we've seen this before. The health experts were in front of Congress saying, we've seen this before. It shouldn't be that bad. It's going to be about 8,000 cases. Last time, that's what we had. Yes, there's death. Oh, does it cause death? That seemed to be a surprise, didn't it? A SARS outbreak that led to death. Wow. Am I being too loud on this lecture? I don't know. Am I? Okay, 37 countries. Wow. No, we can if it's in China, wherever it is, we can isolate that. It'll never spread out of China. We can actually lock down a country and keep it locked down. We can actually close our borders and keep it out of America. Wow. And it was contained, look at this, it was November of 2002 and it was contained in the summer. So if we do have SARS, good gosh, it's only going to be 6 months and go away, right? Coronavirus is the cause of SARS, severe acute respiratory syndrome. It is viral pneumonia, right? That's what scared me to death when I got an email that said, my diagnosis is viral pneumonia, Mr. Rector. Oh my God. Did they test you? Are we okay? Are we treating? What are we doing? Because that diagnosis getting thrown around at this time of year or this time that's serious diagnosis. Symptoms include rapid onset of high fever, dry cough, headache, dyspnea, shortness of breath, and hypoxia. Wow. Those seem like we were surprised by these symptoms, weren't we? Were we surprised? We acted like we were. This virus causes hypoxia. Your pulse ox is going to drop. We've got patients in the ER. We are unprepared. Should we have set up a unit? Do we need a COVID unit for the hospital? Do we need training? Do we need respirators when this first started? We acted like this was a day-to-day experiment, a day-to-day discovery, and we already knew everything we needed to know. But it was like a new learning experience every day. Came out and said, it does cause, it's a fever and dry cough and headache, shortness of breath, and some people experience hypoxia, low blood oxygen, and some people are dying. We got death. This is causing death. The virus is believed to have mutated and crossed into humans from this palm civets. I don't think they brought that animal in this time. 2002, we had a virus jump from an animal to humans in China, originated, and it spread through the world and killed 8,000 people. And we seemed shocked that this happened again, really. And we weren't prepared again. There's the civet. He looks fun, right? Looks cuddly. I don't know, I've never seen one real. During the early phase of disease, only low levels of virus are present in the respiratory tract. Cell cultures used, we use Vero E7 cells, reveal the cell round so we can identify it. We can grow it, we can culture it. We knew that. We knew how to do that. Well, look here. And really, we had nucleic acid testing with PCR is the most useful diagnostic test. Here it is. This has been known since 2002. We were supposed to be ready, right? We were supposed to be prepared. And we seemed shocked. We seemed like it was something new. You can call it novel. We kept harping on it, right? It's novel. This is a new one. We've never had a SARS. Yeah, we had SARS-CoV. That's why we named this one CoV-2. We've already had this one. Had one real similar to it. Pre-warned, killing people, but you see the numbers. The numbers were the misleading guide. They said, look, it's not going to be as bad. But then it was like, oh my gosh, all of Italy has it. Oh my gosh, all of Great Britain has it. Oh my gosh, here's another country has it. Oh my God, it is. Numbers are skyrocketing. What is there a difference? Yes, but we weren't prepared for that. Here's another warning. MERS, Middle East Respiratory Syndrome, cause coronavirus. Middle Eastern Respiratory Illness. This was 2012. You see the timelines? 2002, 2012, 2019. Middle Eastern, we called it that. We called it Middle East Respiratory Syndrome, MERS, COVID. Like other coronaviruses, thought to be spread through infected person respiratory secretions, such as coughing. We want to call it MERS, or MERS is our little unit here, radiology with an I, right? So let's call it MERS. MERS first appeared in the Middle East, 2012, largely been confined to primary Saudi Arabia. Camels. Camels are a reservoir for MERS and can pass the disease to the humans. The camel doesn't die, but here's another one that's doing what? Jumping from animal to human. Got our great picture of Saudi Arabia and the camel. In humans, illness is contagious and potentially lethal. By June 14, when did this start? 2012, right? 681 laboratory confirmed cases, 204 deaths. That is a high death percentage, wouldn't you say? That's almost half of the people that got it died. Symptoms include shortness of breath, coughing, fever. 30 to 40% patients reported have died. So there's our percentage. If this had been ours, right? Oh my, we would be looking at what? We've had 5,000 deaths in Arkansas. Had how many cases? I may not be here. I could be gone. Symptoms, 1/5 have occurred among healthcare workers. CDC officials have said the majority of cases now in Saudi Arabia are not linked to camels, but are associated with person-to-person transmission. Once it gets to the human spreading it to human. Don't have to have the camel link anymore. There have been 2 confirmed cases of MERS in the United States. Nothing to worry about. We've had MERS. It didn't get out of Saudi Arabia. And if it did, it was because it was a healthcare worker that went over and treated and came back or worked on it, World Health Organization, whoever's going over, coming back. Both were hospitalized in the United States and they fully recovered. So the U.S. citizen here has this magic of they're not going to die from it, right? Testing indicates that bats in Saudi Arabia are infected with several strains of MERS-like viruses. Bats, therefore, might also play a role in human infection, according to their CDC. They seem surprised, right? They seem surprised. So I hope that is take-home message number 1, is that this lecture has been, we've had this info from 2002, 2012, and we acted such unprepared, surprised. Do we really need to shut things down? Even today, and I hate to say this, but yesterday was an embarrassment too. I told you I saw some of that yesterday from Congress, but that was an embarrassment. I'm just going to say that recording on my lecture. If we didn't have any cases, we'd be great. We didn't have people you remember how shocked you were last year in March when there was an Arkansan that died? When they first put up the first number that somebody died from this, well, guess what? We're still not at 0. We're still back to where we were a year ago, but we're not as high as we were in the middle. But so be careful. Just be careful. Don't listen to, hey, it's time to go about and do everything like we always did. We're better prepared, but we're still in the middle of this thing. We're not done with it yet. It's not June, July the first time. It's not 6 months later and we've got it all taken care of. Now, we've got the vaccine makers saying what? Do you trust the vaccine maker that comes out and says we may need a boost? What does that tell you as an immunologist? You all are immunologists now. I graduated you in December. What are you? What does that mean to you? When you hear the vaccine company maker Pfizer say we may need a boost, what do you hear as an immunologist?
It's not going away.
You think they got info on patients and antibody levels?
Yeah, they don't know yet.
Yeah, but do you think they don't have any info with antibody levels? You not think they know IgG levels now that we've started vaccinating? You know, we took the trial, right? When did we take the vaccine? When was the vaccine here? When? When did the Pfizer vaccine pop up? December? Was it December, January, somewhere in there? So when did the trial start? So the very first patients weren't given this thing in December. They were given it well in advance, phase 1, 2, right? Remember the phases of trial? So that tells me that those numbers are showing this, okay? It's fading. It's not going to be, they came out and said, yes, 6 months after looks good. Maybe they're starting to see the decline. They won't say that, but when I hear you may need a booster and you may need it again next year, that's telling me that their belief is it isn't going to be long lasting. It's not going to last for a lifetime. It's not going to protect you forever. Okay? Keep that in mind while you listen to the others' ramblings. Okay. All right. So off coronavirus. Hopefully you get the gist of that. So we had to come back and hit it hard that time. Hemorrhagic fever viruses. So like I said at the beginning of the lecture, these are the movie viruses. These are the ones that, oh my gosh, this is what had us so scared of Ebola, right? And we're going to talk a little bit about Ebola and how that actually presented itself here as compared to movies and as compared to what we see when there's an outbreak in a country in Africa. We're going to start with the Lassa. The Lassa virus is our hemorrhagic virus, the Arenaviridae family, single-stranded RNA, significant cause of morbidity and mortality in West Africa. So this is this way in Africa. West Africa is reaching over toward our, the Atlantic Ocean, right? Yes. Sierra Leone, Liberia, Guinea, Nigeria. It was first detected in 1969 in Lassa, Nigeria. Wow. Say one more thing. This is just the way we do things, okay? If it's a person that discovers it, maybe you get your name on here. If it's a region where it's discovered, you're going to see the regions of Ebola. You're going to see a region of Lassa, and we're going to name those viruses. 80% of the cases are asymptomatic. Lassa has been associated with hemorrhagic fever, shock, and death. And that's key to remember because that's how we saw the treatment is key to these hemorrhagic fevers. They're not as scary, they're not as deadly as once believed, or perception, I'll say that. Capillary leak, widespread organ involvement, accompanied by shock, respiratory disease, hemorrhagic are responsible for most of the deaths from Lassa fever, which means that you lose your ability to clot. So you're getting bleeding in places that you're coag specialist now, all right? Put somebody on blood thinner, hemorrhagic, that's what we're doing, right? Bleeding in different spots where we hope not to have it. So here's the area. You're unfamiliar with the African continent, Nigeria, Ghana, here is Guinea, Sierra Leone, Liberia, off the coast. The reservoir host is a rodent known as the multi-mammat rat. Mammate rat. Once infected, this rodent's able to excrete virus in its urine for an extended time period, maybe for the rest of its life. Transmission of the Lassa virus to humans occurs most commonly through ingestion or inhalation. So if the rat urinates on your food or urinates in your water, or urinates on something that you get ingested or inhaled, you end up with Lassa. Droppings, direct contact through touching the rat, eating contamination, food, exposure to open cuts, sores, inhalation of the virus particles lingering in the air. People get infected when the rodent comes into the house and raids their grain supply. Oh, Mr. Director, you can avoid that, right? Not if you got a house on an island that's in the air. It was on stilts, right? They built this house up on the stilts. I don't know how, I guess the rats go up the stairs, but they ended up in there. So here's a picture. Please don't touch your rat. Looks like this guy is spearing rats and they're holding them and carrying them. Person-to-person transmission can occur if there's exposure to blood tissue secretions, right? And that's what we know from Ebola too. Casual contact does not spread the virus, but the Ebola patient showed up in your ER. That's what happened. Person came into the ER with a fever and was shedding virus and came in contact with the nursing staff. And we'll tell the stories in a little bit. But Lassa fever is most often diagnosed by using our enzyme immunoassay technology, which detects IgM, IgG antibodies, as well as Lassa antigen. Reverse transcriptase, RT-PCR, Used to detect viral nucleic acid in the early stage. Virus isolation in cell culture is not recommended because it's unreliable. Lassa fever virus requires a BSL-4 laboratory, a hot zone lab, which means it's on, you're suited up, okay? You're gonna work with Lassa virus in a lab setting. You have to have it locked. You have to have negative air pressure. You have to be wearing an enclosed suit with oxygen going with you. So you cannot come in contact with it. So here's a doctor right here, or medical student, Bob. Bob's out here taking care of patients in the late 70s in Sierra Leone. And Mr. Payne gave this lasting right here. If you never met Mr. Payne, he was known for wearing flip-flops. He wore flip-flops to class. He wore flip-flops to lab. And so this is an ode to him with the wearing the flip-flops, taking care of a Lassa patient. Sierra Leone again, depleted blood volume because they're hemorrhaging. And that is the key to these, is taking care of the patient. The patient can get medical care. Survival rate is pretty good. Pretty good. It's very nice. So, so that's Lassa. Now we got some Filoviruses. Discovered in the 60s and 70s. Most pathogenic of the hemorrhagic fever viruses is the filoviruses. So these are Marburg and Ebola. So they're phylos. So they have a shape. They're not this round coronavirus look to them. They kind of look like a parasite for us. They look like a worm because they're filamentous look to them. There they are. We got a real picture in a minute. The lipid membrane, glycoproteins on the membrane, viral capsid inside, and that RNA wrapped in the middle. Severe multi-system syndromes, this is what happens. So most of the patients that get exposed in Africa to Ebola when they have an outbreak, and you'll see these on the news. To your virology ear, you should hear, when you hear Ebola, right? We just, again, I think since 14, we've gotten to say, you know, that's still over there. Still not going to show up in my ER, but it can, okay? So the patient's vascular system's damaged. And so if we have them in a hospital, we put a patient in the hospital. I remember the story of Ebola was that we had doctors, a dentist, it was a medical doctor and a dentist too. I think it was two, maybe it was a dentist. They went over to treat, right? They go over to the African continent and start treating people for medical conditions or doing free dental clinics, that kind of thing. And there was an outbreak at the time and they got it, right? They were flying them home, right? Going to bring home the doctors that got Ebola. They flew them home. I think they put them up in Emory. If anybody knows where Emory is, it's in Atlanta. And they brought them in, and it looked like they had them like in the iron lung. Like, gotta keep all respiratory, anything away from everybody else with these patients. Gotta have them in total isolation while we work on them. So it was like, oops, well, that's so bad for that doctor. He's gonna die because he got Ebola over there in Africa, and now we're trying to save him. So he survives, right? So it's like, oh, you can survive Ebola. Yeah. So basically, they started having treatment, and actually to the point where this doctor started donating convalescent plasma. Does that sound new, right? You've heard that with COVID. Convalescent plasma, he'd survived Ebola, so he was donating his plasma, which had antibodies to Ebola virus. And we're using that for convalescent treatment of the people that were getting it by these few patients that came through America with it. Okay, so we found out that Ebola is not as scary as the movies make out to be. We don't have blood coming through our eyes and out our ears, and we're not just going to walk in with a blood, look to us and say, ooh, we're dying soon. But that is the story of the patients in a small village in Africa that doesn't have a hospital. They don't have IV fluids. They don't have blood to replenish the blood they're losing through the hemorrhagic fever. And that is the fatality. That, as you see, fatality rate of Ebola virus, this is what has always been, it's 80%. Okay, if you don't have health care, if you don't have convalescent care, if you don't have fluids to be given, you will die, okay? 80% of the time. Okay, but we see a lot of info came out of this 2000, I think it was 2014, if I remember right, that outbreak that ended up coming to America in the way of healthcare workers and others. There were other patients that were here, and they brought it into the ER. And I remember, I think it showed up in Dallas, and I remember one of the nurses that ended up with Ebola was so upset that she was going to sue the hospital for not educating her on personal protective equipment when a patient may come in with a contagious virus like Ebola. And we laugh at that, right? Because we say, oh yeah, we have orientation. And they went over probably that information, but again, we're not expecting it. We're not putting on our gloves. We're not putting on our masks. We're not putting on our equipment unless we know for sure they have something. It's just fever. We're not worried about it, right? And you end up with whatever the patient has. So keep that in mind. So we don't really know where Ebola has a reservoir or not. It is suspected that it may be a bat, and it may be a zoonotic, again, virus, although the exact species is unknown. But what we see is Ebola virus, formerly known as the Zaire virus, the Sudan virus, the Typhus virus, the Bungo virus, the Reston virus, which is non-human. It's got a whole lot of names, right? Whole lot of names. Following initial human infection through contact with infected bat or other wild animals, human-to-human transfer can happen. So again, we seem surprised that the bat is a virus host and it can be the problem with spreading it. So several Ebola vaccines are currently being tested. That would be great. Oh, about vaccines. And I just saw this story. You remember we were just touching on it. I think somebody brought it up in class the other day about the HIV vaccine. And there's a story we'll share after the lecture, maybe tomorrow or Monday. When's the next lecture? Wednesday. But look for it. I just saw it on one of the news stations, which they're actually using. They put it in trials. They're actually using the messenger RNA vaccine technology that we're using for COVID, using it for HIV. And it looks promising in phase 1. So maybe we get something good out of this COVID vaccine development where we can actually maybe make some vaccines with others. So that would be easy, right? You put mRNA for HIV, what? Glycoprotein. We went over those Wednesday, you know, the GP120s and the GP41s. If you can get those out there in the body, right, the body makes antibodies to those. And then if you get exposed to HIV, right, boom, boom, got a vaccine, maybe, let's hope. Again, Ebola is a BSL-4 facility. It means you're going to have to, you know, suit up, we'll put it that way. So here's the Marburg, and this is that filamentous look to it, curls up like a parasite worm. We got Marburg, probably this is one of those uncommonly called viruses. I mean, you may not have heard of this one. Again, it was discovered in Marburg, Germany. Well, the first filovirus was discovered there when a laboratory worker developed a hemorrhagic fever after handling African green monkey tissue while preparing the polio vaccine. Laboratory workers, their families, and medical personnel became symptomatic. Simultaneously, outbreaks occurred in Frankfurt and Belgrade, Yugoslavia, now Bosnia. And that throws off we changed names of places, and I just never understood that. Like once something gets a name, let's keep it straight. I get too confused with these historical name changes. I understand why they do it, but it's like, well, let's just change the name of Jonesboro. Everybody, let's just change it, right? That's not going to go over well. It's going to be hard. But sometimes they do that. Like we're just going to change the name of Jonesboro, Arkansas to Frankfort, Arkansas. That's a better ring to it. 31 people were symptomatic with 7 deaths. Researchers have successfully linked Ebola's relative, which is the Marburg, to a bat reservoir. In 2007, researchers isolated the Marburg virus from the Egyptian fruit bat living in the Democratic Republic of the Congo gold mine, where 154 individuals, most of them minors, had been affected. So we know bats live where? In caves. 5 years later, another set of scientists found it in the Python Cave, a popular attraction in Uganda's Queen Elizabeth National Park. 2.5% of the well-studied colony of the bat, right, the Egyptian fruit bat, the Egypticus colony, was infected with Marburg at any given time. So some Ebola pictures. This is what we see on the news. You know, if there's an outbreak somewhere in Africa, this is the look we have. Many graves, 80%, remember, fatality. There's that picture of this classic Ebola. So not what you would consider, maybe, right, first virus I think you've seen that's not helical or shaped. In 1976, the Ebola virus was first identified in Yambuka, 60 miles from the Ebola River in Zaire, now the Democratic Republic of Congo. 600 people became ill, 430 of those died, 70% fatality rate. 13 and 14, the epidemic resulted in at least 28,000 suspected cases, 11,000 deaths. And I want to say that 2014 case came here. So during that 13-15 epidemic, came over and as those healthcare workers came. Humans became ill after contact infected animal, usually a primate. 76, those caring for the sick who came into the contact with their secretions quickly developed symptoms. PPE was seldom used for those caring for sick patients. Needles and syringes were often not sterilized for reuse, exposing many people through the use of contaminated needles. So it has 5 subspecies. We see there's a Zaire, a Sudan, a Thai forest Ebola, and those are the ones we had on that first picture of those different bats being in different places. So here's the areas in red, cases of Ebola. Here's the green is the Sudan. Purple is Bungu. So into the early 2000s, the group went out to look for the Ebola reservoir. They collected and screened blood tissue samples from more than 1,000 bats, birds, and rodents for traces of Ebola and found viral RNA fragments and antibodies against the virus in 3 bat species, the fruit bat, non-insectivores in this case. The viral load was pretty low, too low to isolate and replicate the virus, so the team couldn't definitively say that bats were the reservoir hosts of Ebola. More than 10 years later, researchers still do not know which species carries the virus. So the Reston infects monkeys. It has occurred in research facilities in the United States. It's known to cause infections through aerosolization. Several monkeys in the cages became ill. So y'all ought to ask Dr. Walls next time you get a say, can she work? Ask her, because she used to work in a primate facility when she first got out of school. So you can ask her about, were they actually doing Ebola testing, Dr. Wall? See if she'll answer that for you. All right. Y'all got any questions? I know I got a little loud on this one, but again, like we talked about yesterday in lab, we have history. We need to learn from history. We need to be prepared, and it's so easy to forget, because we feel like we're bothering people when we remind them. We feel like when we go and testify and tell people what should be going on with the health of Americans, that we get pushback because somebody has a different agenda. So keep that in mind. So when you're the leaders of the health department and the hospital labs one day, you could remember this lecture and scream and holler about, you know, we've had a long history of these. What's next, right? We'll ask that. We'll ask what is next? What's coming next? And that's what some people will say. Well, we never can prepare for everything. But just so we're kind of on top of one, like we knew 2002, we knew 2012, we knew that there were outbreaks occurring, and we just acted like we were sitting here with no idea that we could actually prepare for this, right? We were just going to react if it happened. All right. Y'all have a good weekend, and we'll see you next week.